Hey guys, it's Rod. Welcome back to the channel. In my last video, I explained how I've connected my LG ThermaV heat pump to Home Assistant using the Wi-Fi module from LG. That then connects out to their servers, and I then connect to their servers via the ThinQ API using Home Assistant. So it's a big round trip that uses the internet, it's cloud-based, it's crap. In that video, I'd explained that I'd already bought a Modbus interface, and my intention was to connect this to Home Assistant using Modbus. And today, that is what we're going to do. So what have we got here? We've got a Waveshare RS485 to PoE Ethernet adapter. I'll link to that down below. Waveshare make a whole bunch of different modules, all different form factors and different ways of powering them. This can be either powered using DC input, or it can be powered using PoE. I have PoE switch inside that powers my Wi-Fi hotspots and my cameras. So I'm going to plug this in to Ethernet and power it over PoE. Then out at the top, you connect the serial connection, the RS485 connection that connects to the inside of the heat pump. I've bought myself a little 5-way DIN rail box that I'm going to mount inside, just on the other side of this wall. And this will sit inside there. I'm going to use Cat5e cable for both sides of this. It's kind of overkill for the RS485 bit. Before we open the heat pump, I'm going to switch it off. It's always a good idea. I don't want to kill myself or blow up the heat pump. First thing I'm going to do, probably the first problem I'm going to run into, is I'm going to try and run some Cat5e cable through this duct and see if I can get it to poke out the other side. Because if we can't get this to work, then we're not going to get very far. Yeah, we didn't get very far. I think getting this through the duct is going to be a bit awkward. So what I've done is I've unraveled this cable that was already folded up in here. It goes inside and is quite long. And I'm going to put some tape around them, tape them together, and see if I can't use that as a drawstring to pull this through into the room next door. So a lot of messing around later. I do now have the cable through the hole that the installers left. Didn't bother putting the grommet that you're supposed to put in there in. So we only need 2 cables for the Modbus connection. So let's pick a pair. Let's go with orange. Keep the others for now. Tidy them up. We're going to use the orange pair, and the heat pump is off because, you know, bad juju to be messing around in here with the power on. I think on this we want dip switch 1 to be up, and we want dip switch 2 to be up. Not entirely sure because the manual looks wrong. Yeah. We'll give that a whirl. So now that I've got the cable through, I am going to mount this DIN rail box on the wall here. So this box does come with some glands that you can break the knockout out and you can fit the gland in. But when you tighten it up on this really thin network cable, it doesn't really grab it. Also, I'm inside, doesn't need to be waterproof, so I've just botched it, drilled a few tiny little holes that are just big enough for the network cable to fit through. So that'll do for this application. Next up, you can feed the network cable that's carrying the Modbus connection into the side here. So you can see the Waveshare module is marked with 485A and 485B. So we want these two connections here. Check the connections tight. So that'll sit in there like that nicely. So next up we need a network connection. And as if by magic, I've already run a Cat5e network cable up and over into the loft space here and down into the cupboard next door that has the PoE switch in it. Feed this into the same box. And install an RJ45 connection on the end here. So next up I will plug the network cable in and see what happens. And it's alive. We can fit the cover on here. I did previously plug this in and see if I could get it to work. And when I first plugged it in, before you connect to it from the other end, this light doesn't light up. So you end up with just power and link. So power is power obviously, and link is an indication that the network connection is connected. But when your serial connection, your Modbus connection isn't running yet, this third light here, the activity light, is not illuminated. So if you're setting this up yourself, don't be surprised if initially this isn't lit up. So now that we've got the Waveshare module connected to the heat pump and we've got it connected to the local network, I'm going to jump onto a Windows machine here, and I've downloaded an app called VIRCom. It's available on the Waveshare website with instructions how to install it. I'll link to that in the description down below. Once you open the app, you want to click on Device, and the device should be listed here. If it's not, click Auto Search, and hopefully it will show up in a list for you. Double click on the device. So in here, the only settings I really changed the first time round was to change the network mode to DHCP so that it would get a local IP address. The Waveshare module has a little web server built into it, and it has a little web interface where you can go in and change all the settings. And for me, that's a lot more convenient than getting out my kid's Windows machine, because my normal computer runs Linux and you can't run this app on Linux. The first time round, I came in here, I set DHCP, and then I was able to connect to the Waveshare module from my Linux machine through a browser. In theory, that should be ideal. I should be able to change all the settings that I need, but that's not the case. I logged in there, I had everything set up the way I thought it should be, and I was trying to get Home Assistant to talk to the Waveshare module, and I was failing miserably. Eventually, I came back into the VIRCom app and discovered an extra setting that doesn't seem to be available in the web interface for some reason, but it's super important. In Advanced Settings, under Transfer Protocol, make sure to change this to Modbus_TCP protocol. So once that's done, click Modify Settings, and hopefully we are done with the VIRCom app forever. Next up, we're going to jump into the Home Assistant config and see what that looks like. So I created a new file, a modbus.yaml file, and included that in my configuration.yaml file. We jump over to the modbus.yaml file. I'll link up to all of these from the description down below. I'll put them on my website so you can look through it in more detail if you want to. So the setup is fairly straightforward. You just have to give it a name, a type, it's TCP, the host, the IP address, make sure the port is set to 502. So next up, you can set up all your different sensors. So before we look at that, if we jump over and have a quick look at LG's manual. Inside the manual for the heat pump, it has what it calls the Modbus Gateway Memory Map. It's basically just a list of all of the Modbus registers that you can read from and write to. I've never used Modbus before, and looking at the LG manual and looking at examples in Home Assistant, it wasn't entirely obvious. It took me a few minutes to figure out how the two map together and what all of this means. So I thought I'd just very quickly run through it, try and explain what I've learned, see if it makes somebody else's life just that little bit easier. In Modbus, you have multiple registers. You have coils, you have discrete, you have holding registers, and you have input registers. So in the manual, we have a section here for coil registers. So coils are 1-bit registers, so basically binary values. You can read or write a binary value to a coil register. So you have things here in the manual like enable, disable heating, cooling, enable, disable direct hot water. So you can read the value from that in Home Assistant and display it, or you could have a switch, for example, that will allow you to switch it on and off. Discrete registers are very similar to coil registers. They're 1-bit registers, but you can only read the values from them. So if you look at the sort of things that are in here, like water flow status, direct hot water heating status, it makes sense that those are not things that you can change. You can just read the value from them. Next up in the manual, we have holding registers, but there's a twist. Holding registers are not holding registers. The manual is wrong. These are actually input registers. So input registers are 16-bit registers that you can only read the value from, which is maybe why LG got confused in their manual. So these are things like error codes, inlet temperature, outlet temperature. So again, it makes sense these are only things that you can read. You can't change the value, but they're more complex values, things like temperatures. If we scroll down, in the manual, input register, but these are actually the holding registers. So if you're looking at LG manual, just remember input and holding registers are the wrong way around. So these are the same as input registers, except you can read and write the values. So you've got operating mode, target temperature, direct hot water target temperature. So these are the more complicated values that you can change on the heat pump. The names being swapped is important because of the way that these values get mapped back into Home Assistant. So in Home Assistant, in order to read the value from a coil, jump back over here, so you set the type of the device to coil. So there's one here somewhere. So here we've got a toggle that toggles silent mode on the heat pump. So the write type is set to coil, and the input type is also set to coil. So now Home Assistant knows that it should be looking at a coil register. Now obviously if you went back to LG's manual and looked at the input and the holding registers, because they're the wrong way around, if you tried to put the types into Home Assistant, it would all be wrong. So looking at the example of the silent mode toggle, so that is address to and write type coil. So we jump back to the manual, we can see that silent mode is a coil and it's address 3. So again, in the manual, these are numbered starting from 1. In Home Assistant, same numbers, but they're numbered properly. They start from 0. So enable, disable heating, cooling is address 0, and so on and so on. Silent mode is not address 3, it's address 2. So you have to remember to subtract 1 from all of the numbers in the manual. So then it's just a case of going through and looking at the manual and deciding what it is you want to map from your heat pump via Modbus into Home Assistant. I've gone through and added pretty much everything that I thought was sensible that I might use, or that I just wanted to be able to see, or that I might want to just record and keep. One of the values that I was most excited about was this one, current flow rate. In theory, that should return the flow rate in liters per minute, but it doesn't. Not for my heat pump at least. And if you look elsewhere in the manual, there's a little asterisk that says this feature is only available in certain models, and I guess it's not available in my model. It shouldn't be a big problem. I think the water pump inside the heat pump is set to maximum and to run at a constant flow rate. I don't remember off the top of my head what that is, but I should be able to use that to calculate the COP. So jumping back over to the modbus.yaml file, so we have a quick skim down these. The first entry here is a binary sensor, but is a coil, so it should be a switch. In my case, I don't want it to be a switch, so I've set it up as a binary sensor. I have an external Z-Wave switch, which first opens a motorized valve, and when that motorized valve has opened, it switches on a water pump and then also switches on the heat pump. So I use that to turn my heating on or off, but I do want this to be able to monitor whether the heating is on or off. So you'll see in all of these entries, slave is set to 1, and that is the Modbus address that is configured on the heat pump. So if you've set that to anything other than 1, then that's what you would enter here. So the rest of these binary sensors are all discrete inputs. So they are just sensors that sense whether something is on or off. So binary sensors. Next up, I've got a sensors section, and that is a selection of inputs and holding registers. It's not very interesting. Again, I'll leave a link to all of this on my website in the description down below. I have a couple of switches, one for switching the direct hot water on and off. So that is a coil. Coils seem to have a verify section, so I expect what that does is it will write to the coil and then it will read the value from the coil to check that the value that it's written is actually being returned. And I also have a separate switch for silent mode, another coil. Next up are climate devices. I have set up 2 climate devices, one for the heating and one for the hot water. I'm not going to go into great detail with these. There's a lot of documentation on the Home Assistant website. It's fairly self-explanatory. This is one place that I have run into a problem that I haven't been able to fix yet. So it looks like the HVAC on-off register 0. There's no way to set the type of that, and it seems to be hard-coded inside Home Assistant to a holding register. In my case, it's no use because the HVAC on-off register is a coil register. It's not hugely important because I can't use that device to switch the heat pump on or off, but it would be nice for the climate control to know whether the heat pump was on or off. Finally, if we jump over to this dashboard, this shows everything that I've set up on the heat pump through Modbus and still has the Wi-Fi stuff that I've previously set up. So in my last video, I had connected a Wi-Fi module into my heat pump and was using the ThinQ integration. So this climate device uses that. So do these inputs. So this was what I could get before: hot water temperature, the in water temperature and the out water temperature, the flow and return, and this climate device. And I think that was the extent of what I could see inside Home Assistant. Let me just turn this on. So that will toggle the Z-Wave switch that will switch the heating on. So now I have 2 climate devices, one for the hot water, and I can change the hot water temperature and see the hot water temperature. And I have a climate device for the central heating, and I can change the target temperature and see the current flow temperature. So we can see now that I've switched that on, the heating has just switched on. If I change the target flow temperature here, let's set it to 30, you can see up here in ThinQ, it is updated to 30. And if I change the target heating temperature via ThinQ down to, say, 25, this climate control, there we go, has also adjusted down to 25. So on top of having the 2 climate devices, I've also got all of these values available to monitor, and some of them I can change. So the water flow temperature is, again, a big disappointment because it always reads 0. So having a quick look at some of the values I've got available. So in, out, I've got the outdoor temperature available that I didn't previously have. I've got the hot water status. So one thing I previously couldn't see was whether the heat pump was in direct hot water mode or was in heating mode. The heating could be on, but the heat pump could have switched over to do direct hot water. And the only way I would know that is because the power consumption would go through the roof. But now I can see if the direct hot water is on. You can see there it was on this morning and briefly this evening. I can also see when the compressor comes on and off inside the pump. I think this one is the water pump inside the heat pump. I can see when that is on and off. So another interesting value that I didn't have before, I can see the heat pump disinfect status. So that ran this morning for 45 minutes. So the disinfection cycle is something the heat pump is programmed to do once a week, in my case on a Wednesday morning in the off-peak time. So because heat pumps generally heat the water to a lower temperature, in my case normally 50 degrees for the hot water that comes out the taps, The water that's stored in the tank is sitting at 50 degrees and could in theory develop Legionella. So once a week the heat pump heats that up to 60 plus degrees in order to kill any bacteria that could develop in the tank. So it's important to be able to check that that is running as it should be. So far I'm just getting started with this. I'm going to switch over all of my automations to use the Modbus controls, and another thing I'll probably do is change the hot water schedule so that that is scheduled from Home Assistant rather than hard-coded on the heat pump. That will allow me to do things like enable a holiday mode, so if we're not at home it doesn't have to heat the hot water up, things like that. Makes a lot of sense, I think. And just like that, the Modbus integration is complete. The possibilities for control are now limitless. Okay, maybe not limitless, but you know, more than before, and it's all local. I no longer have to rely on the internet, on LG servers. It should just work.